Well, this is it. Good afternoon, TCCA. I'm a tier. This is the last session of the day. Thank y'all so much for being with us. It has been awesome. We are going to close this out with Tom Reardon, and I'm going to bring him in in a second. Remember that if you have questions or comments or concerns, you go ahead and throw them in that comment box, and we will look at those, and I will share those with Mr. Reardon. I also have Jamila. I say her name different every single time. Robinson. It's not even a hard name, and I've known her for like 4 years. She will be also monitoring questions, and she will also be punching me in the head next time she sees me for butchering her name every single time. Also, be tweeting hashtag TCCA 2020, and look forward to seeing y'all next year. But I'm going to bring on Mr. Reardon, and I'm going to shut up.
Okay.
If you want to share your screen.
Yeah. Thank you, Chad. Oh, geez. All right, so let me just make sure this is showing. Is it showing okay?
Not yet. It hasn't populated yet.
Okay.
Also, we're waiting on that. I threw up the register for EdCamp. The bit.ly is up there, and make sure you check that out. And there's the hashtag again. Tweet at us at TCCA.conf and hashtag TCCA 2020.
Showing yet?
No. Are you seeing the share screen on the bottom?
Yeah.
And
I'm clicking on, it says screen sharing tips. I'm saying share screen.
Share screen, and then I believe it only gives you one choice to pick on.
It actually gave me 100 choices.
Oh, you must have a lot of screen. It only gives me one. So
no, I mean, I'm literally 100. I don't have 100 screens.
You have your entire screen, and that's the only option it gives me is your entire screen. Yeah, you got to click on that and then click share.
It's not giving me any options anymore.
There, let me share mine. So
I'll try to share mine. Anything coming up?
No, it's not populating inside the studio. Let me make sure. So will give me the option to take over yours. And folks, we did it. He's already presented once, and we got the screen sharing. So I don't know what the issue is.
Just log out and come back in.
You can come out, and I'll just hang in here and wait for you.
I'll just do that. Okay.
Okay. Sorry about that, folks. We'll start in a little bit. How's the conference going so far? Let's just do some rifting here. Well, hello, Miss Owens. Paul, thanks for hanging strong. Hello, Jocelyn. I've had a blast. I believe they are having some kind of session at 6 o'clock, and it is on Sched. So if you check the Sched, you can check that out. I got some weird news that I'm not able to give you your secret password until the very end because I don't know it. I'm waiting for them to. I only got the first 7 session password, so I'm waiting on 8. Terrific, going great. It's been incredible. Oh, thank you. Like I didn't do anything. All I've done is shown up. Uh, Now, this has been an excellent conference. And when you get your survey, make sure you fill it out, and we'll know next year to either be virtual or going back to face to face. Your guests will need to connect their mic before you add them to the stream. Are they giving out prize? Oh, I wish. That's the worst part about going virtual is we're not doing the draw at the end. That was one of my favorite parts. People screaming and yelling and running down the stairs to pick up a flash drive. And then someone won a big screen TV at the end. Hold on, let me mute myself. I'm going to need you to call this person because I got kicked out and they're trying to get back in.
What do you mean? Who kicked them out?
They didn't get kicked out. They left because they couldn't share their screen. So they left to try and rejoin. And also it's showing me as TCCA 12.
That's okay.
That's but at the end, it doesn't matter. All right, let's see TCCA 11. Let's look up his name.
Live, right?
Yeah.
Okay.
They know we're having conversations.
You
Look.
want me to entertain them while you look?
No, because you're calling. You're Mr. Call.
You're calling. I will entertain. Go ahead. Hey, while Chad goes ahead and tries to get a hold of the presenter, Brad Kaplan here. I'm actually a lot more entertaining than Chad. So, are we going to give out prizes this year at the end? Well, you don't know till the end. So, the prizes are that you're here with Chad and I. That is a prize for you. Also, Tom is still trying to get in.
Your guest will need to connect their mic and cam before you can have them.
Yeah. So Tom they're on the hotline right now. Chad is on the hotline. And with Tom, we put out the bat signal and we're waiting for. Yeah, we're going to send him an invite right now. Put it up there and we're going to send it to him. We are doing this fast and furious. And we're going to get it back up and running. We're sending him hotline right now. Tom at. Here it comes. Here we go. Let's get this on. So what put in the chat here while we're waiting. What was your thoughts on the virtual conference? Did you like it? Would you come next year? I am better. It says it's going great, but it's been incredible. Tons of information, very informative. Amanda says, thank you for offering the conference. Amanda wants to know, of course, the most important thing is, are there going to be prizes this year? Don't know. What was your favorite? Which year was your favorite? Which theme was your favorite? My favorite was the Lego one, like Chad said earlier. Get PD hours. Everybody got VIP parking. There we are. Here we go. We're ready. We got them. All right, folks. No problem. Okay. Tom still needs to share a screen, and I'm going to give it back to ground control. Tom.
Okay. Here's where ran into problems. I've got literally 50 things to share my screen.
Yeah.
I mean, I have a lot of things open, but well, let me do this.
I'm wondering, can you what's your presentation? And you might
Can
get
you see? Can you see this?
Yeah, I got
Is
that.
that showing? And
It
if
says
I change it to this one, does this work? Families of functions.
no. I'm just seeing quick review how to graph.
It's only letting me show one page.
Yeah, it won't give you share your entire screen. What's your presentation in? Is it a PowerPoint?
Smart notebook.
Oh crap! I don't have that. Let's see. I attended absolutely last year. Let's see. How can I get your presentation where I can share it?
You're not going to be able to do it. I have too many things open. And we just had this working.
Yeah, that's what's weird.
My browser has blocked my screen. All right, can you see me, hear me again?
Yeah, I can see you.
Here we
But he
go.
said
I got it. I got it. I think I got it. Now you can see it?
Yes, sir.
Okay.
All right.
Sorry about that. So we'll go ahead and get started. I hope people are there. Is there anybody still there? You can tell me if there isn't.
Yeah, you have 18 people.
Okay. All right. Well, sorry about the delay. And we're finished by when?
4:50. 4:50.
4:50. Okay. All right. So families of functions. This is a complete online course with
3:50. Sorry, I said 4:50.
Yeah, 3:50 your time.
Sorry. Sure. Go ahead.
So my name is Tom Reardon from Ohio. Fitch High School for 35 years and at local university for 40 years. Senior math advisor for Texas Instruments full-time for 11 years. All of my both of my talks today are at this website, so strongly encourage you to write that down. It is lowercase, should be easy to remember. bit.ly/TCCA 2020 should be easy to remember, and I'll explain what's on there as we go along. I always like to start off with a quote. I'm not going to bypass that, even though I'm running late. I'm convinced that students can learn in more ways than I know how to teach. And this was by Stephen Reinhardt from a great article, Never Say Anything a Kid Can Say, from the mathematics teacher 20 years ago. So with that, let me talk a little bit about this. This is families of functions, transformational graphing modular unit, which means you can only use what you want or need. There's 200 videos, but you may only want 6 of them. Okay, so you pick the 6 you want. We created it for remote learning, but it also complements in-class learning and can work in a flipped classroom, independent study, or just review as needed. Okay, we created it so it's multiple ways of use. I will tell you this is a very different presentation from what I normally do, not because it's remote, but because I probably do about 50 to 100 presentations a year, and it's usually interactive math. And this is more about how can you use materials that we've created. So I have spent, no exaggeration, over 400 hours creating these materials to help you and your students learn and teach how to graph the parent functions and their transformations. So the mathematics and pedagogy I normally would be having you do with me are in those videos. I'm mainly going to be showing what they are and how to access these so that if they sound like something you want to use, you can easily use them. They're meant to be how a teacher would teach these concepts and allowing the student to pause and try ideas. It's not just saying, do this, do this, do this. We're still trying to have them discover the math, create their own learning. So the first thing we're going to talk about is there's a section on how to graph each parent function. There are 12 of them, parent functions that we thought, and these are the 12 parent functions. The 13th one is a generic piecewise function that we use sometimes, but you don't memorize that one. So somebody might say, well, I don't teach e to the x or natural up. Well, don't use those. You just use the ones you want, okay? And we have a coding system that will be a little more obvious as we go along. 0, 1 means the parent function is the squaring function. P means you're graphing the parent function, okay? 0, 2 would mean you're graphing the absolute value parent function. And you might say, well, how is that? Well, the videos are 5 to 9 minutes length each. This is like they've never graphed y equals x squared before. We have a quicker version, but this is as if they've never seen it. It also discusses key terms like intercepts, asymptotes, vertices, domain and range, a practical application of the graph, okay? Right now, the website is under construction by Texas Instruments, so we're using one I created that's not so pretty, but I will show you what the pretty one's going to look like by the time we're done. So you would go to the website, it would take you here, and you'd click on whichever one, or your student would click on whichever one they were to do, okay? The homepage for this is pretty much links you to other websites. Like if you clicked on how to graph the parent functions, it would take you back to this, and you'd pick the one you want. If you wanted to do the quick graphs of the parent functions, which I'll explain in a minute, that would take you to that part of it. The transformations, we say there are 6 of them, okay? Horizontal, vertical, vertical stretch and shrink, f of negative x, the opposite of f of x, okay, and one more that, dilations. So dilations, there's 26 videos here, vertical shifts, horizontal shifts, whether a graph is even or odd or neither. The quick graphs of horizontal stretches and shrinks, opposites of parent functions. And then this one's a combination. This has 39 videos in it. Linear equations is now in progress. We're hoping to have that by the middle of November, but all the other ones will be done. So the quick graph each parent function, okay? These are a series of 12 videos. They're only 1 to 2 minutes each, and they're there to show that how to quickly do this, like you've already seen it. So what I'm going to do is, I could show you the videos. I don't think that's a good idea. What I'm going to do is I'm going to show you the slides that I use to create the videos, because I think that would be much more instructive for you, okay? So here is, I created the slides on Smart Notebook, which is for smart boards, but it's a great canvas, a lot of color and so on. And think of these as cartoon things where you kind of flip it and you get kind of an animation type deal. It's kind of like that. I'm going to go through these videos much faster than you would for a student. Normally a student could pause it also, but I want you to get the feel for what they're doing so that you can say, yeah, this is something for me, or no, it is not. So the first one is how to graph y equals x squared. And we're going to use the parabola dance and use proper vocabulary. You'll need graph paper and a pencil. And if you don't have graph paper, you can download a PDF that has 20 grids on each side that you can print out. And we're all going to encourage students to press pause as needed anytime, okay? So I'm going to go through this as if there were the video. I'm just not going to play the video so I can go faster, okay? All right, so you're given a grid and a table, and we're going to use these 7 values for x. And so 3 squared is 9, and I'd say complete the table, and students would hopefully pause the video, I hope, and would complete the table. And then once they're unpaused, I'll show them what the values would look like and then encourage them to do it with the negatives there. And so these are the 7 points. So we'll go ahead and plot them. 3, 9, 2, 4, and so on. And again, they can go as quickly or as slowly as they need to. And I'd like them to notice patterns here. And there's patterns in this. So for example, look at 3, 9, negative 3, 9, and look at the graph. Look in the table. Look in the table. Look on the graph. What's going on here? Table in pink, and so on. And what I'm hoping is they'll notice that this is symmetry, that the points are symmetric about the y-axis or the line x equals 0. And also, since this is their first time, some students might think this is like a v. And so to answer that, we're going to look at two other values for x, when x is a half and negative a half. And when you square a half, you get a fourth, which is a surprise to some students, unfortunately. And when you square negative a half, you also get a fourth. So when I plot those ordered pairs, you can see that no, it is not a V shape. It is really more of a U shape, and we call that a parabola. So connecting the points, this is what y equals x squared looks like. And again, you can pause at any time if this was a video. Some terminology, we call the vertex 0, 0 at the bottom there. That's the vertex. And this line right here, we can call it a mirror line, but we prefer to call it an axis of symmetry. And then we show that axis of symmetry by showing that they're equidistant from there in opposite directions. And then to graph this, we're very big on calling these basic graphs have dances so that students can plot them relative to different points. So the parabola dance starts at the vertex 0, 0, because 0 squared is 0. And then from there, we go right 1 up 1 because 1 squared is 1, right 2 up 4, 2 squared is 4, and right 3 up 9 because 3 squared is 9. Left 1 up 1, negative 1, the quantity squared is 1, left 2 up 4, and left 3 up 9. Again, we connect the points, and that would be our graph of the parabola. Again, notice that it is symmetric about the y-axis. These are all things I want my students to understand. Domain and range is also included, so we show the graph with a little bit of a table and say the domain, well, if you look here, all these x values green all have y values above them or on them at the origin. So the domain is all real numbers in words, and in symbols we use a script R. The range, these are the values 0 and everything above it, so it's all positive or real numbers in 0, which we would write that with set notation. Also, as a real world thing, this is a picture taken from the World War II Memorial in Washington, D.C., just to show where you could see parabolas in the real world. So that's one video of many, okay, from what we call the parent graphs. There's also, once you do the parent graphs, there are quick videos, usually only 1 to 2 minutes each of these. And so I thought, and these, again, the emphasis is on quickly. Students don't want to watch videos for very long, but we want to make sure they have enough there to get them going. So this would be, if you go to the quick parent functions, it's Q in the same numbering system, okay? And then let me show you one of those. And then I'm going to ask for questions or comments. So if you have, see what you think so far. So let's go ahead and look at this one right here. This is a quick review of how to graph y equals the square root of x by hand quickly. And we're thinking that we're going with the assumption that students have seen how this has been developed. So they just need a quick review, like, we did that a couple weeks ago, but I forget. So again, they have the grids if they need it. So the radical dance, we'll go and start with the initial point at the origin, 0, 0, because the square root of 0 is 0. And then we'll go ahead and do our dance. From that point, it's right 1 up 1. The square root of 1 is 1. But right 4 up 2, the square root of 4 is 2. Right 9 up 3, the square root of 9 is 3. If I had room, I'd go right 16 up 4, but I don't have room for that. So we'll go ahead and connect the points, and we get our y equals the square root of x. And that's pretty much it. That's just a quick review. I think it takes about a minute to do this video. And realize that the quick for all of these, there's a quick graph for all of these in that same vein. So let me just stop there for a minute. Please unmute yourself. Don't chat to me. We only have a few people. Does anybody have any comments, suggestions, questions? Thumbs up, thumbs down, thumbs in the middle. Is this something that you could use? I can share the smart presentation. So let me show you what will be shared. This website I did the SAT in the morning. So the families of functions online. This presentation, as soon as we're done, I'm going to post it. Okay, so it'll be a PDF of that. The website with the links to all the videos will be there, and the PDF that explains all the videos, which I haven't shown you, will be there as well. Texas Instruments is developing an easy-to-use website for these, and it should be completed by November 10th. So hopefully that answers your questions. Any other questions in the chat? Okay, so thumbs up from somebody. Love the way you explained the points in a pattern. Okay, so got a couple people. So thank you, Jocelyn and Abdallah, for that. All right, so let me go a little bit further. Hopefully this is keeping your attention. So the third part of this is explaining the transformations in general. And so based on me teaching for many, many years, this is how I would teach this idea of dilations. And these are anywhere from 8 to 20 minutes. I know those are long. We field tested with students and they said they're long, but they're necessary. They couldn't see how I could trim them down and still get the concepts across. So I'm going to show one with you so you can see that. So there's dilations, for an example, would be like y equals 3 times e to the x. Vertical shifts, here's an example also, y equals 2 to the x minus 3. Horizontal shifts, y equals the greatest integer of the quantity x plus 2. Horizontal stretch or shrink, y equals the natural log of quantity 2x. The opposite of function, y equals the opposite of x cubed. And evaluate at the opposite of x, which is different sometimes, y equals the square root of the opposite of x. And we do point out that each of these videos should be viewed before they do those transformations. So don't go to the vertical shifts part and do some quick ones if you haven't seen how we explain it, because it's based on understanding that. So for example, if you're going to graph this and you haven't done the vertical shifts video, this might not make any sense to you, okay? And we're hoping they only have to watch those once, and then these will be the follow-ups. So again, 6 videos, length 8 to 20 minutes each. There's a website with that's going to look a lot nicer when TI gets around to it, okay, than when I had. So let me just show you one of those so you can get a feel for what that's like. So this is investigate the graph of f of the quantity x minus h, okay? We're going to do it by hand, by table, with technology, and then let the students generalize it, okay? We're only going to do a shortened version of this that I made for you guys because this is a lot longer video, but at least you get an idea of what I'm talking about. So we'll start with y equals x squared, and we're going to go ahead and graph that using our parabola dance. And then I ask the students in these longer videos to pause until they're finished doing that. Really hope they do. It's really helpful that they do, but you know some of them are just going to say, I'll just wait until he tells me. Okay, I'll just watch. All right, so 0 squared is 0. Right 1 up 1, right 2 up 4, just like I did before. I could also use symmetry to get the other side, but however that works, okay? So I want to get those 7 points. All right, so I connect the points, and we've got our y equals x squared. Now, keeping an eye on the parent function, I'm asking them to do this. Remember, this is in a video. Let's go ahead and graph this, and we'll make a table with 7 rows. And the values for x will not be obvious until after we're finished, okay, while we're developing this. So I'm going to ask them to complete the table. That is, substitute the numbers in for x and calculate those y values. Press pause until you're finished doing that. Again, I hope they do. And then once they hit unpause it, it will come back and share what the y values are. And I also put here how I got them, so they can see how those numbers were arrived at, okay? I plugged in 7 and got 9, plugged in 6 and got 4. Hopefully that will help. And then we want to go ahead and connect the points, plot them and connect them. And this is our graph. And so I'm asking them, how are the graphs similar? Go ahead and pause, think about that, okay? They are the same shape. How are they different? And hopefully think about that. And it's, again, I've been shifted, the graph points have been shifted to the right 4 units. And I show it for a few of them from blue to green. They're going to the right 4 units. Okay. Not just those points, but all of them are shifted to the right 4 units. Let's go ahead and compare and contrast the tables. So these are our y equals x squared table values. And go ahead and look at how they compare and how they contrast. And hopefully you can see some things there. And you can see that the y coordinates are identical, but the x coordinates to go along with them, you can see that going from the parent function to the one we're doing, you add 4 to the x coordinate. And you say, hey, wait a minute, I thought we would subtract 4, but it turns out we have to add 4 in order to be able to get it to shift to the right 4 units, as it did. So I'm having them try to understand that the x minus 4 shift goes to the right and not to the left. I want them to understand it, them to discover it, not just me say, just do this. So I'm teaching on the videos as if I did in the classroom. So all x coordinates are increased by 4, and that comes from that part of the equation. It's reversed from what you thought it would be, and the y coordinates stay the same. That's what I'm hoping they came up with. So if they didn't get it, I will eventually tell them, of course. So we say that the graph of y equals the quantity of x minus 4 squared has a horizontal shift right 4 from its parent function y equals x squared. We want to use the proper terminology, okay? We want to make sure they get that. We're going to repeat the same with a different equation, but we're not going to do that. I'm just going to show you what the results would be. You got the idea. I'd go through the same type thing and say that this is a horizontal shift left 3 because of that plus 3 inside the squaring function. We also want to know if it holds true for other functions besides y equals x squared. So we're going to use technology. And so I'm going to show pictures of technology that shows y equals the absolute value of x in a dashed blue, and then y equals absolute the quantity x minus 1 in green that shows not only the graph, but also the table. And you can see how this is shifted to the right 1, shifted to the right 4, shifted to the right 5, left 2, left 4, looking for patterns and seeing how that goes. Instead of making them graph all those, which takes a lot of time and make mistakes, you know, can they see the pattern here? And it seems to hold true for all functions. Showed it for the reciprocal function, okay? Show how it sees for the reciprocal function, and they would have more time to look at these, by the way. And then one of my favorites is to bring in some kind of piecewise function, because that's not something they can memorize, and see what happens when you do f1 of x of the quantity x minus 1, minus 2, minus 3, plus 1 to the left, plus 2 to the left. And also showing the tables when they make sense. So then we have a summarizing of this, okay, where h is some constant. When h is greater than 0, that is positive, the graph shifts right horizontally h units. And when h is negative, the graph shifts left horizontally, the absolute value that many units. And then always on our quick ones, there's always a now you try one to see if you got it. We don't go through a whole lot. We just want them to do it for the practice. Ask them to pause, resume when you're finished to check, and all we do is show the answer. We don't show it again. We're trying to keep the videos shorter. So this is one of our investigations. I'm curious what you think of that. If you could just take a second and put something in the comments to let me know that you're still there, or if this is working for you or not. Like I said, we field tested this with students and teachers, but not done this nationally. So I'm very curious what you're thinking.
Some of the one of the questions was more of a direction, but please show how we open this platform. Is it free? What free online graphing calculator do you recommend?
Okay, so is this free? The answer is yes, absolutely. This is free. And I'll get to in fact, the website that I showed you has a link to where all these things are. Okay, so the platform we're using, since Texas Instruments is budgeting this, they're using either TI Inspire or TI-84 to do this. All those things are done, but you don't have to be using a calculator at all. The videos do everything. So good questions, good suggestions. Love the comments. I'm glad you're happy, at least almost as happy as I am, maybe. So.
Yeah, lots of good feedback. I love the way you explain the points as pattern for the vertex. I've always pointed out the difference between each point.
Okay.
Got a thumbs up. Thank you. How would I write comments on the graph beside the graph?
How would they?
Yeah, they're asking how would they
well,
put a
so
comment.
remember, these are all videos, so the students would be watching them. They won't be able to edit the videos, but the videos are just there. They are. We're also going to be working on, though, Google Forms and PDFs that go with this. And what the Google Forms would do, I don't know how many of you, is Google Forms something that's used much in your district?
Yes, big time. We're a Google district.
Okay, so what we're going to have is we're going to have a Google form for almost each one of these, where it'll like walk you through it, and then inside the Google form, you'll click and the video will play right in the Google form, or it'll take you to YouTube where you can see it. But as far as writing on them, I don't see a way of doing that. Though you can email me later, and I can try to, if you can explain what you mean by that, I may be able to answer that later. All right, so teaching the graph transformations, did that part, I think. So dilations, there are 26 videos, even though there are only 13 parent functions. We did one of each, one where a is greater than 1, and one where a is between 0 and 1, okay, for this. As far as negatives, that's done in the combination one when we do the opposites also. So there are two different ways. We use one using the dance and one using a table. And at the end, we always have a now you try one. So really, even though there's 26 videos, there's really 52 problems because there's always a now you try one. So there's a lot of examples for students to get, some experience. So looking at the time, so I do want to show you how the dilations one looks. I think if I have that one. Do I have that one? Oh, I guess I don't. So, all right. So let me just go to. I'm running out of time anyway. So let me just go to this one. I don't think I showed this one yet. Did I? Given f of x, how would you graph y equals f of the quantity x plus 4? I don't think I did that one yet. So this would be another horizontal shift. And so we don't know the dance for this function, so we're going to use a table this time and see what you think of the table method. So to do this, we have to identify the key points on the graph and then place those coordinates into a table. So I'm going to make a table here. And the first point I grabbed seems pretty obvious. I'm going left to right, -3, 2. Next key point, -1, 0, 0, 1, 1, 3, and then 3, 3. And now what I have to do is create a second table for the transformation. And I have to remember that the x plus 4 inside makes me subtract 4 from each x coordinate. That was something I learned from that main transformation video. That's why those need to be watched first. And so I'm going to subtract 4 from each of the x coordinates. So -3 minus 4 is -7, but we're going to keep the y coordinate the same at 2. And then we'll plot that point, -7, 2. -1 subtract 4 is -5. Keep the y coordinate the same. Plot 5, 0, and so on. And I'm just going to flip through it so you can see subtract, keep, plot, subtract, keep, plot. We can go slower on the video. Oops, added a page by mistake. Sorry about that. Subtract, keep the y coordinate, plot. And now what I have, after I've got them, I need to connect the points, but keep in mind, I have to use the original function for the shape. And so I have to make straight segments where there are segments and curves where there are curves. So we get that. And now what I do is compare it to the parent function and see that going from blue to green, it's left 4, not at just these 3 points, but all of those points. It's shifted left 4. So that would be, and then there's a now you try one. Given this function, what would be f of the quantity x plus 2? Press pause to do this, resume, and then we show the answer. It's shifted to the left too. So there's, like I said, like 200 videos like this. Hopefully this is something that you can use. All right. That's a here's a vertical shift. Let's look at this vertical shift one. This one's done two different ways. Okay. A problem because it's reciprocal function with asymptotes and so on. So the first way we're going to do is what I call the reciprocal dance. Okay. Identify the center point. Now, normally the center is at the origin, but because of the -3, all the points are shifted down 3. So our center, which is normally the origin, is going to be shifted down 3 at 0, -3. So that's going to be kind of like our new origin in orange, by the way. Through the center, draw the asymptotes with dotted lines. We explained the asymptotes previously. And so at y equals -3 will be one of them, one of the boundary lines. And the y-axis, x equals 0, will be the other one. And now we've got that center point. And from that center point, we can plot 6 key points. One of them is right 1 up 1 because the reciprocal of 1 is 1. Right 2 up a half, the reciprocal of 2 is a half. And right a half up 2, reciprocal of half is 2. So those are 3 in my new first quadrant, so to speak. The other 3 points will come from left 1 down 1. Reciprocal of -1 is -1. Left 2 down a half, and left a half down 2. And now that we have enough points to kind of give us an idea of the 2 branches of the hyperbola, we can go ahead and draw those in using the asymptotes as boundary lines. So there's a quick way of graphing y equals 1 over x minus 3 using this idea of a reciprocal dance. And we compare it to the parent function and can see that from blue to green, yeah, everything's been shifted down 3 units. Okay, not just those points, but all of them. But a second way is using a table. Now, I always was a big fan of the first way, but I was told to use at least 2 ways in these because it depends on who it'll appeal to. So here's my 6 points on my regular hyperbola, 1 over x, y equals 1 over x. And so the -3 does not, or -3 does not affect the x values. So I'll leave the x values alone and subtract 3 from each of the y coordinates because that's right there in the equation. So 1/2 minus 6/2 is -5/2. So I'll plot that one. 1 minus 3, -2, 1 comma -2. 2 minus 3, -1, a half comma -1. And then I'll do the other points similarly. And because I've done these before, I'm now able to probably figure out where the asymptote lines, the boundary lines are going to be as dotted lines. So I'll put in y equals -3 and x equals 0 again, and then connect the points to make the 2 branches of a hyperbola. Some people like the table, some people like the dance. I hope you like at least one of them. And then we always compare to the parent function to get a feel for that. And at the end of each of these is a now you try one. Graph this one, use either method or both for the practice, okay? And when you're finished, resume when you're finished to check it. And again, we just show that it's been shifted down too. We don't get in a lot here. We want to keep the videos as short as we can, but still be instructive. Whew. So we did start short. We did start late. That's on me. I get that. So let me see what else we've got. We got dilations. We got horizontal shifts. We've got vertical shifts. Stretches and shrinks are really tough. I wish I had time to show you the stretch and shrink derivation, but you can watch that at your own. It is 17 minutes, but necessary. That's a tough one. Like absolute value of quantity 4x and the square root of the quantity 1/2 x and natural log of 3x. Those are tough things to teach students, okay? Opposite of each function, those are pretty much a little bit easier. And then we do f at the opposite of x, so we can talk about whether or not functions are odd or even or neither, okay? And then the ones I just did, combinations. So I think I can do that. Stop me if I don't have time to do that. Oh, there was the one I was missing.
Yeah, you got about 4 more minutes.
Okay. So Combinations. Yeah, let me just find that one real quickly. There's my alarm reminding me. So let me just show you the combinations real quickly. And there are 3 of them in there because we wanted to be a low level, medium level, high level. And so you can see all my work to get there. So let's do an easy one on us. Let's not get crazy. Maybe not. We'll do a 1/2. There we go. So this one is 1/2 or negative 1/2 times. It's a squaring function. It's got 4 different parameters in it. This would be one of the harder ones for students to do. And please load. Please do not get messed up on me. There it goes. Here we go. And so you can see I created these as the scripts, and then when I recorded them, what I just did with you guys is how I recorded them, but again went slower, okay, because, well, they're students. All right, so here's what I want to graph. Y equals negative 1/2 the quantity x minus 3 squared plus 4. I mean, we got the plus 4, we got the minus 3, we got the half, we got the opposite. I mean, this is a tough one. So the first way is deciding the parent function and what its shape is. And so the squaring tells us a U-shaped parabola that looks like this. Kind of keep that in mind. Identify the parameters. Those are values in the expression that affect the graph. Negative 1/2, minus 3, plus 4. How do they affect the graph? The plus 4 shifts all points up 4. Those affect the y's. Minus 3 inside the function shift the points to the right 3, as we talked about before. The negative 1/2 multiplies each y value by negative 1/2, so it opens downwards. Okay, so what do we consider first? Well, we consider plotting the vertex first. And so there's going to be a right 3, which can move our vertex from 0, 0 to 3, comma, and then up 4, 3, 4. So we'll plot that. The parabola dance. Now, normally it's right 1, up 1, but because of that negative 1/2, it's going to be, again, relative to the vertex, it's going to be right 1, down 1/2, because what we're going to do is, normally it's right 1, up 1, but we're multiplying by negative 1/2, so it's going down 1/2. Normally it would be right 2, up 4, but it's going to be right 2, down 2. Negative 1/2 times 4 is negative 2. Instead of right 3, up 9, it's going to be right 3, down 4.5. And again, on the other side, we'll get a similar idea there. So this is how we're using that dance idea. And then we'll go ahead and connect the points. We know where the vertex is. We know where the axis of symmetry is. Okay. And then we compare it to the parent function. And then we go ahead and do it using a table. But I think we're running out of time, so I'm going to kind of stop that. But you get the idea. So let me kind of pull this all together. You have the bit.ly, and this is the SAT materials. Here are the other ones. I do need a few minutes to make the PDF of this presentation so that you'll have that. So if you could come back, in about 10 minutes or so, or even tomorrow to be there. But those are the information. Let me get to the end of this also. Oh, this is what the page is going to look like. It's going to be, you can see it's going to be a lot prettier than what I've been showing you. Okay. This is what they're going to have. They're going to be different modules that you can go to, different explanations. And you can see this is a representative because they have Latin for this to kind of show you what it is. But this is what it's going to look like, hopefully by November 10th. I'm also working on a linear equation set of videos to add in November to that same thing. First, they told me not to do it, but now I'm going to. And we're going to have slope intercept, point slope, standard form, talking about slope. So a lot of stuff on linear stuff there too. So if you have questions or comments, I would love to hear from you, tom@tomreardon.com. This is the website with all the materials. I hope you can use these, and I'd love to hear how it works for you. And I am still looking for a couple of field testers. People would like to try with their students and just tell me how it's working, or if they find mistakes or suggestions or whatever. So again, love to hear from you. I'm in the Houston area a lot. My best friend lives in Houston. I'd come down several times, but that was when we did things in person. So, Chad, if there are any final things,
No, that was the feedback. The feedback is fantastic. You're getting a lot of love, especially for the language that you used. You're getting a thank you, and I love the phrasing you use, parabola dance.
okay.
So,
Okay, well, hopefully this is something you can use. Again, I'd love to hear from you, and thank you for inviting me. Thank you for letting me come, and I'm sorry I didn't get to go further. We had that technical glitch, but have a great afternoon and weekend, everybody, and thank you, Chad, for your help.
All right, thank you, sir. Guys, the password is at the bottom. The password is success. So to get your certificate, use success. We're going to end it there. Thank y'all so much. Thank you, Mr. Reardon. Thank you, Shamila, and I said your name right that time. Thank you to our YouTube watchers, Paola. See y'all next year.